Yeah, good evening. Today I would like to explain my conference topic on assessing the role of machine learning models in groundwater contaminant monitoring and management. This is Dr. Asadi, and my colleagues are Dr. Alvin and Professor Laureate Ravi Naidu. And under CRC Care, we have implemented this conference paper. And welcome. And these are the contents I would like to explain: introduction, aim, objective, methodology, results, discussion, future directions, conclusion, references. Coming to introduction, we have implemented groundwater contamination poses significant environmental and public health challenges, and these methods are for managing groundwater contaminants have limitations regarding accuracy, efficiency, and scalability. And if you see that there are various machine learning, deep learning, AI in artificial intelligence techniques we are using in order to predict groundwater contaminants. And based on previous studies, I have collected 10 closely related literature survey papers, and I have done a deep study on that previous papers. And this is the literature survey of contaminant monitoring and management. So there are 10 papers closely related to my topic, and there are common drawbacks I have find, and what is the existing system, proposed system, data sets used, tools and techniques, and future work. So according to Jenga and his team, and in his paper, inefficiency in handling complex contaminations. Likewise, existing system they have used conventional remediation techniques. In proposed system they have used AI, ML, and DL approaches for site remediation. Data sets they have used data from various contaminated sites. Then tools and techniques like AI, ML, and DL techniques. And future work, further development of AI, ML models for more complex contamination scenarios. Likewise, 10 authors information I have collected. This is the groundwater quality and contamination risk data set. So well ID and location and pH level and TDS, nitrate and heavy metals, water temperature, pumping rate, season, previous contamination events, and finally the contamination risk target value is low or medium or high. So likewise, on this data set we have applied a hybrid CNN and RNN technique, and machine learning techniques in groundwater management we have applied, and we have provided enhanced decision making capabilities. We have improved accuracy and faster processing time by incorporating various frameworks in Python and machine learning techniques like CNN, RNN, XGBoost, random forest, and convolutional neural networks we have applied. And the main objective of our research topic is aims to assess the effectiveness of various ML models in groundwater contaminant monitoring and management. We have used neural networks, decision trees, regression models for assessing machine learning models. Model is nothing but simplified version of the reality. Contaminant detection, environmental monitoring, and management strategies. And finally, we have come up with improved accuracy and enhanced decision making. Then this is the groundwater contaminant monitoring with machine learning techniques, and we have collected from various case studies. We have done 10 case studies. So case study name, country, groundwater models they have used, and methodology, why this application, results, and the reference. Likewise, we have used various case studies, and we come up with good literature survey models. And finally, we have applied machine learning methods like address contamination issues by analyzing case studies and data and performing comparative analysis to manage groundwater pollutants. And this is the proposed architecture we have used. Out of 10 case studies, we have used for training data 70%, for testing 30% we have used, and we have applied various machine learning methods, and we have done training, testing, and validation schematic. And first step, data collection. There we have applied sensors, groundwater samples, remote sensing. Then we are doing data pre-processing. We are eliminating noisy data, redundant data, inconsistent data, that is called feature extraction. We have applied data cleansing, normalization. Then we have chosen model training. We have applied neural networks, decision trees, regression models. Then finally, we are applying model evaluation with help of validation, cross validation, performance metrics. Finally, we are taking decision making, action plans, policy development, remediation strategies, etc. So these are the discussion of results. Successfully, we have applied all the machine learning algorithms and deep learning emulators, artificial neural networks, and optimized models for enhancing groundwater monitoring accuracy and efficiency. We have applied advanced deep learning methods like convolutional neural networks and recurrent neural networks. And finally, we have enhances monitoring accuracy and efficiency. So these are the model applications we have come up with. Deep learning emulators like deep neural networks model we have done, convolutional neural networks. There we have used SmartFlow, optimized machine learning models. We have used XGBoost. It is a framework in machine learning, and these are the future directions. Successfully, we have analyzed various case studies, and we have done a recommendation for improving machine learning algorithms using real time data, and broadening their use in various environments for enhanced groundwater management, and refining machine learning algorithms, integrating real time data, expanding applicability, better groundwater management. So, finally, I am concluding my presentation of my conference paper. Machine learning models perform traditional methods in managing groundwater pollutants, especially PFAS, in simulating contaminant movement and optimizing monitoring networks. So these are the references. I have used 10 references, and thank you for giving me this opportunity.